Okay, we're going to continue on with 9.3, and we're going to be covering DeMoivre's theorem. It's an extension of what we were doing with the trig form of complex numbers in the beginning of 9.3. But now what DeMoivre's theorem does for us is it allows us to multiply trig functions of complex numbers to any power. So we don't have to actually multiply them out anymore. We can just use DeMoivre's theorem. If you remember, our formula for the trig form of a complex number says that I have r times cosine theta plus sine theta. That's the trig form of our complex number. Well, what if I wanted to raise that to some other power? Well, DeMoivre says I can do that by taking r to the nth power and multiplying it times the cosine of n times theta plus I sine of n theta. So let's try that out. If I have 5 cosine 30 degrees plus I sine 30 degrees, and I want to raise it to the third power. Well, DeMoivre's theorem says I take r to the nth. Well, r is 5, and our power is, so I have 5 to the third times cosine of n, which is my power, 3 times 30, plus I sine of 3 times 30. Well, 5 cubed is 125. Cosine of 3 times 30 is 90. 90 times 30 is 90. Cosine of 90 degrees is 0. And sine of 90 degrees is 1. And if I multiply that out, I get 125 times 0 is 0. And 125 times I1 is 125I. So I have now raised that trig form of the complex number to another power and put it back in standard form. So let's use DeMoivre's theorem to work backwards. What if I want to find a root of something? What if I'm given something like this? Well, this really means that I have 4i, that's my imaginary part of my complex number, means I didn't have a real part, so that's worth 0. So this is really what this problem is saying. So it helps us to put this in standard form. Now, I can rewrite this as 0 plus 4i. I can remove it from the radical and put it to the 1/4 power. So all I did is rewrite that without a radical. And now I have to change it to the trig form. Well, you have to work backwards and think to yourself, what happened here to make this answer? And we've had enough of these answers that hopefully it'll come to you. But what happened was we had 4 as our r times cosine of something plus I sine of something, and cosine of something here has to equal 0 degrees. Well, cosine times cosine of what degree is going to give me 0? That's 90. And sine of something that's going to really equal 1, because 4 times 1 is going to give me 4i. So that's also 90. So 4 times 0 is 0, and 4 times 1i is 4i. And all of this, now we can grab our power. All of this is to the 1/4 power. So here's what I was looking for. The trig form that led to this standard form that we have up here. So now that we have that trig form, we can use DeMoivre's theorem. And DeMoivre's theorem for finding roots looks like this. The nth root of r times the cosine of theta plus 360 degrees times k over my power. And we're going to do that same thing with sine theta plus 160 degrees times k over my power. Copy that down real quick, and I'm going to clear the page so we can start over fresh. So, if I use what I had my standard form looked like, my trig form looked like this. 4 cosine 90 plus I sine 90. That was the trig form that we came up with based on the problem we started with. So, I need to find the number of roots that I had in the roots to begin with. So if I have the number of roots equals n. So in this case, I started with the problem 4th root of 4i. So I am going to find 4 roots of this problem. So you get to do this 4 times in this row. So for the first root, I have the 4th root of 4, because my DeMoivre's theorem says, which is on the other page, I have let me copy down DeMoivre's theorem real fast so that we know what we're looking at. Nth root of r times cosine of theta plus 360 times k over n plus I sine theta plus 360 times k over n. There's DeMoivre's theory for finding roots. So I'm looking at this. My n is 4. That's how many roots I have. That goes here. And my r also happens to be 4 in this problem, because that's what my trig form tells me. So I have 4 to the 4th times the cosine of theta is 90 degrees plus 360 times k. Well, k always starts with 0, so when you're finding the first root, k is going to be equal to 0. And it's going to be 0, 1, 2, 3, on until you get to 1 less than what n is. So if n is 4, then n minus 1 is 3. These are all the k's you're going to use. The k is going to be 0, 1, 2, and 3 in the 4 problems you have to do to find the 4 roots of this problem. So in this case, we're starting with 0. And it's all over n, which is 4. Actually, yes, it's 4. Plus I sine, same thing, 90 plus 360 times 0 over n. Let's 4th root of 4. 4th root of 4 is really the square root of 2 squared, which is, or the 4th root of 2 squared, which is 2 to the 2/4, which is 2 to the 1/2, which is the square root of 2. If you didn't follow all that. see me. I'll help you figure out how to find those. So fourth root of 4 is really square root of 2 times cosine of 90 plus 360 times 0. Well, 360 times 0 is 0, so I just have 90, and n is 4. And the same thing happens down here. 90 divided by 4 is 22.5. So here is your trig form of this problem. And we also want, they ask for your answer, the roots in trig form and in standard form. So you have to go through and figure out standard form. The easiest way to do this is completely on your calculator. Plug this entire thing, using correct parentheses and all, into your calculator, and you will get standard form. And in this case, it looks like 1.306 plus 0.5411 I. Your calculator will give you the I, and you also have an I in your calculator. You should. So just make sure you put it in there using correct order of operations and parentheses and stuff like that, and your calculator should spit out your answer nicely for you. And you're going to do this 4 times because we have 4 roots in this problem. No problem, we had the 4th root of 4i. So we are going to have 4 problems to work out to find the 4 roots of this problem. And k is going to be equal to 0 in the first one that we do. K is going to be equal to 1 in the second, 2 in the third, 3 in the fourth, and then you're finally finished. Okay, what usually happens in all of our lessons is we figure out how to do something, and then our problems start to look different and we don't know what to do. So number 23 looks like this. X cubed plus 125 equals 0. Looks absolutely nothing like the last one that we did, does it? Well, we need to make it fit the pattern. So let's try and solve this a little bit. If I say x cubed equals negative 125, all I did is subtract 125 from each side. So now I have x cubed equals negative 125, then x equals the cube root of negative 125. Now I have something that I can solve that looks like, I need to write a 3 there, don't I? The cube root of negative 125. So all I need to do is change it to look like something that I can solve. I'm going to find the 3 roots of the square root of negative 125. And let's see, 24 is very similar. It says x to the 4th equals 81. The reason I'm showing you this one, oops, that's not what it says at all, is it? It says x to the 4th minus 81 equals 0, which becomes, if I add 81 to both sides, I have x to the 4th equals 81, and so x equals the 4th root of 81. Looks like it'd be really easy, and it is, and it follows the exact same pattern as the ones we've done before, but in your book they treat it much different, and I think if you treat it exactly the same way that we've been treating this, you'll be fine. So the answer in the book, the solution guide, does look a little different, but if you do this problem exactly the same way that we did the last one, you'll be fine.